So what is fertilization? Fertilization is just formation occurred by fusion of sperm and female nucleus, which is previously called as ovum. Then gametogenesis begins from primordial germ cells, which is itself derived from epiblast. So the primordial germ frame reaches yolk sac by 4 weeks, then moves to genital ridge by 5 weeks, and then it differentiates into either spermatogonia or oogonia according to gender. But if the spermatogonia doesn't reach genital ridge, but instead it is stuck in the neck area, then it will cause formation of oropharyngeal teratoma. If it is stuck in the sacrococcygeal region, it forms sacrococcygeal teratoma. Then primordial germ cell is pluripotent, that it can form all the three germ layers. Then what is totipotent cells, which can form embryonic and external tissue, and the totipotent cells are present up to the 8 cell zygote stage only. Then about cell division, meiosis 1 is the direction division, that is the chromosome number is halved in the meiosis 1. Then let's come to spermatogenesis. So testes has two compartments, interstitial compartment and seminiferous tubules. The interstitial compartment has Leydig cells, which release testosterone. Seminiferous tubules has germ cells, which are in various stages of developments, that is spermatogenesis occurring, and Sertoli cells, which are called nurse cells. And so main hormone is testosterone. Then Sertoli cells have tight junction, which form blood-brain barriers, so that anything that is in system circulation, hormones or any other factor, will not affect the spermatogenesis. Cells which form blood barriers, Sertoli cells, which lie outside blood testis barrier, Leydig cells, because they are interstitial cells. Then spermatogenesis begins at puberty in males. What happens at puberty? Spermatogonia differentiate into two types, dark and pale. Then what happens in the pale spermatogonium? It will divide into primary spermatocyte. It is just a mitosis. Then primary spermatocytes will go into meiosis 1, reduction division, into secondary spermatocytes. Then they go into meiosis 2 and lead to formation of spermatids. So spermatogonium, mitosis to primary spermatocyte. Primary spermatocytes will have meiosis 1. So you can remember this as 1 will have this one. So primary spermatocytes enter meiosis 1, then secondary spermatocytes go to meiosis 2, then spermatids. So this is called spermatogenesis. Then these spermatids are not mobile and not mature. Then so spermatids undergo transformation after that. After spermatogenesis, that is formation of spermatids, they will undergo transformation which is called spermiogenesis to form sperms. So sperms are released in the lumens of seminiferous tubules like this. This is a transaction. So the different layers of the seminiferous tubules and released in the lumen. Then what happens is spermatogenesis takes place in seminiferous tubule. It takes 74 days. Then spermatogenesis is transformation of spermatids to sperm. Here there is no meiosis, no division occurring, just formation of head and tail and these kind of things. So what happens is spermatogenesis. The nucleus will form the head of the sperm. Mitochondria will form the middle piece of the sperm. The Golgi apparatus will form the acrosomal cap of the sperm. Centrioles will form the neck of the sperm and the tail of the sperm. So this is the structure of the sperm. These are the mitochondria and the middle piece. Neck is formed by the centrioles and tail is also from the centriole. In head we have acrosome, which is by Golgi apparatus, and nucleus, which forms the main part of head. Then the fertilization span of sperm is 48 to 70 hours, that is 2 to 3 days. Okay. Then these sperms the sperms that are formed in the seminiferous tubules are non-motile and immature. Then they have tail, but they are not motile yet. So they are into retices. Then retices releases them into epidermis. So in proximal part of epidermis they attain maturity, and in distal part of epidermis they attain motility. So epidermis also acts as a reservoir until ejaculation. So three things occurring in epidermis. There is maturation, there is motility gaining. Okay, so distal parts give motility, proximal parts give maturity, and then they also stay there until ejaculation. Then comes capacitation. So spermatogenesis, then spermiogenesis, then comes the part our maturation, and motility gaining in epidermis, and fourth is capacitation. So then the sperms stored in the epidermis are mature but cannot fertilize over yet. So this the final capacitation of fertilization is capacitation which will occur in the female tract cervix. So after capacitation, what occurs? They become hypermotile. Then time is 6 to 8 hours for capacitation. They attain motility in distal part of epidermis, but they become hypermotile in female cervix. So time then, if sperms remain in vagina for more than 2 hours, they will become immobile. And okay, vagina serves as a reservoir for sperm for 2 hours. If they stay for more than 2 hours, they will become immobile. So the male part is written. Let's go to the female part. So begins in intrauterine life, unlike the male counterpart in which where it occurs in puberty. So process gets started but arrested. So the from oogonia undergo mitosis to form primary oocyte, but it is then arrested in the meiosis 1 and in the diplotin stage of prophase. In so what happens in this arrested phase? This primary oocyte is starting surrounded by flat cells which are called follicular cells, and this is called primary follicle. So when the newborn is formed, its ovary has many primordial follicles. So ovary is a result of millions of follicles, and what happens in menopause, which is also called as ovarian failure? During menopause, what happens? There will be no follicles left, and the test for ovarian result is just the count for the primordial follicles. So this arrested state is called dictate stage. Okay, and there is no arrested state in spermatogenesis, so no dictate stage in spermatogenesis. So what this arrested stage resumes that after puberty, when the HPX matures, the hypothalamus is GnRH which stimulates in a pulsatile manner, that is on a monthly basis. Then that GnRH will stimulate pituitary, and pituitary will release FSH and LH. Okay, so what will the FSH do? The FSH will stimulate the follicular cells, the LH will stimulate the primary oocyte. The FSH what will do is, it will start increasing the layers of the granular cells. So that the primordial follicle, that is the primordial follicle is just primary oocyte and a single layer of follicular cells which are flat. Then after stimulation from FSH, the sum of the primordial follicles will convert to primary follicle. Then the cells become cuboidal. And what happens in secondary follicle? So here it is. So in primordial follicle, there is just primary oocyte surrounded by a single layer of flat granulosa cells. Then after stimulation from this FSH, they will convert into primary follicular, which has two things going for it. One, the primary oocyte will be covered by zona pellucida, and the second thing will occur is that the flat granulosa cell will become cuboidal granulosa cells. Then this primary follicles will convert into secondary follicles. Secondary follicle will have thing that they had zona pellucida from before, but the granulosa layers will become more than one. This will occur in the secondary follicle, but there will be no cavity, that is antrum, present yet. This is the main feature to identify secondary follicles under imaging of ovary. Then comes to tertiary follicle, or pre-ovulatory follicle, or dominant follicle, or antral follicle. What happens is there is development of cavity. Okay, and the cells that surrounded the primary oocyte also divide in two groups. One that are just in the vicinity of the primary oocyte are called cumulus oopharicus, and the cells that connect the cumulus to the whole granulosa layer, these are called discus proligerus. Okay, so what is this is happening? The primary follicle, then the primary follicle, okay, this is done. So this is done by FSH. Now LH. So meiosis 1 is hormone dependent, and dependent on which hormone? LH surge. So LH causes the resuming of meiosis 1. So then meiosis 1 resumes and there is division of chromosomes, reduction of chromosomes. Then this from primary oocyte meiosis 1 resumes, it will form secondary oocyte and first polar body. Okay, both will have same composition 23x 23x. Then secondary oocyte from primary oocyte, this is called ovulation. This resuming of the meiosis 1 and formation of secondary oocyte is called ovulation, which is LH dependent and occurs after LH surge. Then graphene follicle is a tertiary follicle just before ovulation, that is just before the formation of the secondary oocyte, and it is 18 to 20 mm size, and this size is really important. So then comes, after graphene follicle, what happens? The secondary oocyte will undergo meiosis 2, and this meiosis 2 here will be arrested in the metaphase, and this will resume when, at the time of fertilization, when the sperm has attached to the ova or the female pronucleus. So first polar body is released at the time of ovulation. Second polar body is, that is the division of the secondary spermatocyte into the ova and secondary polar body. This will occur at the time of fertilization. So the fertilizable span of the ova is 12 to 24 hours, that is up to 1 day. So maximum number of follicles at 5 months, which are 6 to 7 million at birth, 1 to 2 million at puberty, 4 to 5 lakhs. Then come to structure of a secondary oocyte. Now come to structure of a secondary oocyte. So we will have to know the structure of secondary oocyte because we should know the layers that the sperm will require to penetrate for the fertilization. That's why we need to know this structure. So secondary oocyte is formed after the ovulation and it has cumulus oviricus. So this is the primary oocyte. Okay. Then it has this secondary oocyte. Okay, not primary. Secondary oocyte. So in secondary oocyte, there is perivitellin space because there is a vitellin membrane and between them is perivitellin space, and the first polar body is here. So till the graphene follicle or the mature dominant follicle, the primary oocyte was there, so there was no perivitellin space. But after the meiosis 1 was resumed, that is ovulation occur after the LH surge, this primary oocyte will convert into secondary oocyte and polar body, and there is a vitellin membrane is formed around there, and this perivitellin space is where the first polar body is present. Okay, so this is the situation. And now outside this vitellin membrane there are the granulosa cells which are the cumulus oviricus cells, because they are just in the near vicinity of this secondary oocyte and they are arranged in the sun rays like pattern. That's why they are called corona radiata. Okay, then what happens is, then outside the, so primary oocyte just had our zona pellucida. So just outside vitellin there is zona pellucida, and outside zona pellucida there are our corona radiata cells which are arranged in a sun-like pattern. Then events just before fertilization. So ejaculation occurs, then 2 million sperms are ejaculated in a one time, which will enter the cervix and there will be capacitation, that is the sperms will become hypermobile and only 3 to 500 will reach the fallopian tube, 300 to 500. Then sperm attached to corona radiata, this outer layer. This first thing is called capacitation. Second phase is called acrosomal reaction, when the sperm had the acrosome attached to the corona radiata layer and HL is released, which will dissolve the corona radiata. Okay, then after dissolving this, the sperm will reach up to the zona pellucida layer. Okay, then after attaching itself to the zona pellucida layer, what happens is, there is receptor. Only one sperm will attach to the zona pellucida with the help of receptor, that is ZP3, Then the sperm will get entered into perivital space, and meiosis 2 will be completed in the ovum. That means the secondary oocyte will be converted into second polar body and the female pronucleus or the ovum. The head will attach to the oocyte membrane. Then the cortical granules in the sperm will reach cortical enzymes, which will do what thing? They will make the zona pellucida hard and inhibit binding of another sperm. So this is to prevent polyspermy. But in some condition, the polyspermy develops where more than one sperm join, fuse with the zona pellucida. This is called polyspermy, and example is partial mole where dispermy occurs. Then let's come to gestational and fetal age. So let's assume that this is the 14th day where ovulation occurred and fertilization occurred. So the obstetrician that counts the gestational age, they count from the first day of the LMP. Okay, because in our menstrual cycle we take the menstrual days in starting. So they ask the last menstrual period and when it started. So gestational is from first day of the last menstrual period. But the embryologist, they count fetal age or embryonic age or post conception age. So fetal and post conception, they already signifies after the day of fertilization. So they count these from day of fertilization. So gestational is fetal age plus 2 weeks. So now comes to growth periods. So embryologists have divided the growth periods of the conception of the fertilization into 3: pre-embryonic, embryonic and fetal. So in pre-embryonic, there is from the day of fertilization to 2 weeks, but in gestational age terms, this will be from 2 weeks of gestation to 4 weeks of gestation. The embryonic period is 3 weeks to 8 weeks, here is plus 2. Fetal period is 9 weeks to delivery, and here the most teratogenic period is this 3 weeks to 8 weeks period.